In this tutorial, you'll learn how to solve a quadratic equation by simply using square roots. So a quadratic equation is generally written in the form ax squared plus bx plus c. And we've learned so far how to solve this by factoring and then setting each of those factors equal to 0 to find the solutions. But if you have a middle term that is missing, whether it's actually equal to 0 or whether it's some x squared term equal to a constant, you actually do not need to factor if you don't want to. You can simply square root both sides to find your solutions. So let's get started. Here's a pretty simple example to begin with. Right? I'm thinking of a number, and if you square it, it's equal to 25. What most students forget, though, is that the inverse of a square is a square root, which is the easy part. And that's how I isolate x. But what some students forget is that there are actually two separate numbers that when squared will give you 25. And that's positive 5 times positive 5 or negative 5 times negative 5. And since both of those numbers work, you can write your answers side by side like this, or you can take a shortcut and use this plus or minus sign if the digits are matching, right? So if we have a positive 5 and a negative 5, we're going to use this symbol right here. It's called the plus or minus sign. So I read this, that x is equal to plus or minus 5. And that's the only work that I need to show, the inverse step of squaring and square rooting. Let's try another one. Again, don't forget to show your work by square rooting both sides of the equation. And don't forget that your answer has both a positive and negative solution. So these are pretty basic, but sometimes you can be asked one where maybe you don't have that square root memorized, right? Like this one here. Usually anything higher than 10 or 12, most people don't have memorized. So you pick up your calculator, and you're going to use your square root button, which on the TI-84 is right above the square key. So if you go diagonal from the number 7, you'll see up in blue here the square root sign. So I press the second x squared key, and then I enter my radicand. That's the name of the number underneath the radical sign. And there we go. So it looks like our solution here will be positive or negative plus or minus 16. All right, give these a try and pause the video. When you're ready, check your answers. Okay, let's see how you did. Try this bonus one down here. If you have a calculator, it's not that hard. So the first one is plus or minus 6. Second one is plus or minus 1. And hopefully you got the challenge right as well. All right, let's include a few more steps in our solution process now. So for this one, although I could bring the 100 to the other side here, and I could solve this by factoring because it's the difference of two squares, we're practicing just solving by using our square roots today. So I know this can be solved by factoring, but that's not the skill we're practicing. So the first thing we want to do is isolate this x. That means we need to get rid of every number, whether it's a constant or, in this case, a coefficient. So we're going to divide both sides by our coefficient, and that gives us our new sentence here. This one's fairly basic. Square root both sides, and I get plus or minus 5. All right, let's try another one. All right, so let's remove our constant from this left side here. One should be 5. And then we'll clear our coefficient by dividing. And let's see, that's going to go into 25 times. And then we square root both sides. And don't forget your plus or minus sign. All right, that wasn't too bad. All right, one more. Let's add 8 to both sides here. Okay, now let's see what happens this time. Now, when I divide here, I do not get a whole number. So what I'm going to do is I'm going to leave it in fraction form. I don't want a decimal. I just want to leave it in fraction form because you'll actually notice here that when you square root a fraction, it's actually the same as square rooting the numerator and square rooting the denominator. And that's actually not so bad. This problem's not so bad because 9 and 16 are perfect squares. So that means that my answer will be either positive or negative 3/4. Okay. Now, a decimal answer would also be acceptable, but we generally want you to keep it in fraction form because sometimes the fraction is not a perfect square, and we would leave it with this radical sign or this square root sign in our answer. We'll get to that in a minute. All right, I think it's time for you to give these two a try. Let's see how you do. All right. So we got plus or minus 4, and then this other one we got plus or minus 6/5, right? If we leave it in fraction form, 36/25, and we square root that. Okay, now let's talk about what happens if the number is not a perfect square, right? If a number is not a perfect square, like this one here, then your answer is going to be what we call irrational. And when our answers are irrational, we tend to keep them in simplest radical form. So I'll show you what I mean by that. Now this one doesn't require much work, but we'll get to some that require a little bit more. So the square root of x squared is x. The square root of 7 is irrational. So we leave our answer as a square root, just like this. Let's say 7 is prime, so there's no way that we can simplify this square root of 7. Let's try another one. Okay, so this one, once I isolate x squared, and then I take the square root of both sides, I actually still have an irrational number. Let me show you what I mean. If I turn my calculator on here and I take the square root of 8, you'll see that it's irrational, right? It goes on forever and has no repeating pattern. However, the square root of 8 can actually be simplified. So this might be a new concept for you. So simplify. Yeah, there we go. So pay attention. The square root of 8 can actually be written as a product of two numbers instead of just an 8. So I can say 1 times 8. I could say 2 times 4, right? So those are all the factors, but I want you to notice something about one of these factors. Do you notice that that factor is a perfect square? So technically the square root of 8 can be rewritten, excuse me, I forgot my plus or minus sign, see? The square root of 8 can actually be rewritten as the square root of 4 times the square root of 2. So we can actually take these two factors and we can separate them into two separate radical or square root numbers. Because when we do that, we get something that actually can be square rooted. So when you can split it, if you're able to pull out a perfect square, you do. And if the other one is not a perfect square, you simply leave it right next to it. This is called simplest radical form. It's when you take a square root number and you break it up into factors, and what you're looking for is one of those perfect squares. So 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, etc. So anytime you're trying to simplify, you're going to go through this list and you're going to try and see if any of these factors could be used. Let me show you another example. All right, I'm going to add 126 to both sides, and that would give me this. I'm going to divide both sides by 2, and that would give me this. And now I'm going to square root both of these numbers. And the square root of 63 is not a perfect square. So first thing I do is write my plus or minus sign because I forgot that last time. And what I'm going to do is I'm going to look at the number 63. And I'm going to go back. Let me steal these numbers from the other page. And I'm going to try and think to myself, do any of these perfect squares over here, do any of these perfect squares factor into 63? Like, is 63 divisible by any of these perfect squares? So obviously I can't pick any number bigger than 63. So I'm looking only in this section. I'm going to start from the top. Obviously 49, no, 36, 25. So like, I'm not sure about these. So I could certainly use my calculator to guess and check, right? So 63 divided by, I know this isn't right, but I'll just show you anyways. Okay, nope, not a whole number. So I try again, 63 divided by 16. Nope, not a whole number. So then I do 63 divided by 9. Aha. So 63 can actually be factored into 9 and 7. And that can be separated into two separate products, right? Square root of 9 times square root of 7. So now, when I take the square root of 9, it becomes a 3 with no radical sign. And the square root of 7 is left over. So the answer to this question is plus or minus 3 square roots of 7. All right, let's try one last question. So again, isolate your x squared. Um, 75. And then think about all of those perfect squares again, right? So when you go to square root both sides, think about whether or not any of these perfect squares are factors. So again, it's got to be less than 75. I pretty much know those won't go in. I think that's my winner. 75 is 25 times 3. Perfect. So we have the square root of 25 and the square root of 3. This one can be square rooted, this one cannot. So I square root 25, out comes a 5, and the square root of 3 remains behind. So the answer is x equals plus or minus 5 square roots of 3. Okay, pause the video and give these 3 a try. Ready to see how you did? Did you remember your plus or minus signs? Were you able to factor them into perfect squares and then square root those perfect squares? Hopefully you were. All right, that concludes our video on solving quadratic equations using square roots.